Saxon Math Course 2. Today we're on lesson 70 and we're going to be discussing a kind of a new idea, the idea of volume. And volume basically consists of three dimensions. And I've listed just a couple of examples here, and of course there are more, but like inches cubed and feet cubed and centimeters cubed, as opposed to area, right? Area was just base times height. There's only two dimensions. That's why we have inches squared and centimeters squared and feet squared. But that's not what we're talking about with volume, because with volume we add a third dimension. We add height, width, and length. So there's three things. So literally it's 3 to the third power. So this 10 is to the 1, this 10 is to the 1, and this 10 is to the 1. Hence we get 10 to the third power in this cube, which is volume, or 10 times 10 times 10. And if we do that, we know that that is 1,000. Okay, so the volume of this cube, 10 times itself 3 times, is equal to how many zeros? Well, 3. And there we go. We've got our volume. So today is all about finding the volume of a cube. So in example 1, and I'm going to be on page 490. Example 1 says, this rectangular prism was constructed of unit cubes. This volume is how many unit cubes? And you notice on this particular face, it has 3 cubes deep, right? And then it's 3 high. And the side of it actually has 4. Okay, 1, 2, 3, 4. So those are the 3 things that we need to know. We want to know how the face of it, which is 3. We want to know the height of it, which is 3, and we want to know the length of it, which is 4. Okay, so 3 times 3 is 9. 9 times 4 is 36 cubes. All right, and we know that. Spell that right, cubes, not cubs, cubes. All right, so we know that because of the third dimension that we have here, and we've seen how to solve for volume in other ways as well, but this kind of gives you a real easy way to see the explanation with all those little cubes that plug into it. All right, let's go to maybe a little bit more challenging one. Let's go to example number 2, and in this one we have the height of the box as 3. Let me draw it here to finish out. Let me get these lines in here so it looks a little bit closer. Okay, so we have 3, and the face of it is 5, and the depth of it is 4. Okay, so what we want to do is we want to kind of do our own cubes here. We want to see if we can get those to equal out. There's 5, and then if we did 4 down here, 2, 3, 4. Okay, so how many cubes would be in this volume? Well, it would be 3 times 5 times 4. I like to look at it this way. 5 times 4 is 20, and then 20 times 3 is 60. So there are 60 total cubes in this particular layer. Okay, pretty simple. We've got 3 dimensions, and you can see them very clearly in 3 ways. Okay, height, base, and now W stands for width. Okay, so pretty simple how to do this, but we're going to do a couple of others. All right, so look at example 3, and we've got another cube here. Draw my lines. See if I can get this to look kind of symmetrical. And this is going to be 4 by 4 by 4. Okay, so how many cubes is it going to be as far as the base is concerned? Only the base this time. So we're only looking at these 2 dimensions. Well, notice it only asks for the base. That means we only have 4 times 4. 4 times 4 gives us 16. Now if we wanted volume, we would do by the height, and it would be 16 times 4, but we're not after that. We're only after the base. Okay, so that means it is in inches squared, not inches cubed. Inches cubed would mean that we have done the third problem. Okay, so volume's not that difficult, but I do want you to make sure that you understand what they're asking for when they ask for just the base or the entire volume of the whole thing. Okay, all right, what if they give you an example, a look that is a little bit different? Okay, so I'm going to draw this block here. Okay, and how we're going to demonstrate this or show this is through a little bit more of a kind of a little bit more extensive drawing. Okay, so here we have a height of 4, here we have a length of 8, this up here is 4, we have 4 here and 4 here. So what we're going to do is we're going to figure out the volume of this whole cube. Now what I like to do is I like to take the bottom first and kind of do it this way. So these lines indicate this bottom tier. Okay, and in order to find volume, I'm going to take 4 times 8 times 4, and I'm going to satisfy this whole bottom end here. Okay, so 4 times 4 times 8, that's the bottom. And then to solve the top, I know that it's 4 high, right? I know that it's 4 wide, and I know that it's 4 deep. So 4 times 4 times 4. When I add both of these up, I have the total volume. Okay, so I just wanted to show you that that's the case. All right, so we have 128 here, and then 4 cubed is 64. We add both of those together and we get 192. And then I think it's meters, no, centimeters, I guess they gave it to us. So each of these are centimeters, cm, and it would be cubed for my answer. Okay, so don't let shapes like this discourage you. It's the same thing. I just break it into 2 different blocks. Okay, I do the bottom one and then I separate the top one out and basically make them into the same things, right? So you can do that and you can find out each of these separately and added together give us our answer. All right, that's your lesson dealing with volume. If you have any questions, please let me know and I will be more than happy to help.